So, what are we doing on Mars, or why we're doing it?
So on Mars, we're going to be going there and we're going to be scanning the surface to make sure there's like good moisture, good soil, and kind of like mine through to get some resources so we can build and habit the planet so we can get people there and make sure it's safe and healthy for plant crops and everything.
Alright, so how are we going to do this?
So we're basically going to build something with an Arduino so we can like scan the surface, and we're going to have a computer that will tell us if it's safe or not, so we can start like building stuff on Mars and planting anything we need. Hey Sebastian, what's the use of the sensor?
Well, okay, so we're measuring moisture, and the reason we're measuring moisture on the surface of Mars is to essentially check if the surface is firm enough to allow for heavy machinery so it doesn't fall into the ground. The machinery will have like these poles that kind of extend into the ground, but if the soil is like dampened too much by water, then the machinery will fall into the soil, and that will not be good because that would waste money. So we're gonna actually check around our plot where we'll start on Mars, and we're going to check using a rover. We're going to check the moisture in different areas to determine where is the best places to set up machinery. The rover will compile it into a spreadsheet and a visual data to send it to our data managers so they can tell us where are the best spots to set up the machinery so that there aren't any safety risks.
Okay.
So should we use bars?
I don't know. There's not like a lot of info on that for the sensor itself.
Maybe perhaps some sort of like moisture density per unit or something? I don't know.
That would be, I don't know, it would be dependent on the soil itself and its variable change.
Maybe some sort of saturation level?
Yeah, something that you can consistently measure again and again.
Yeah, that seems like a good measurement. What do you think, Carson?
And our sensor also has to work on different types of terrain because Mars has, like, it has ice towards the caps of it, and it has different kind of terrain in different places. So we need to make sure that it can get into the terrain.
I was looking at the sensor, and it goes up to like 872, so we could use like a percentage maybe or something.
We'll just like compare the we'll like put the max value, or the value over the max value to determine the percentage.
Okay. Yeah, we can do that. Alright. Alright, what like percentages are we gonna use like to be safe?
Well, I mean, if there isn't enough moisture, it could be bad, but I don't think that's really relevant here. So we need, if there's too much water in it, it's going to overall be a problem because the soil would be too damp. So we need to decide a percentage. Perhaps maybe like, I don't know, like under 20% is certainly safe. I think we can all agree upon that, right?
Yeah, anything over 35 or 36 is just going to be completely unusable. Because the machinery will just sink into the ground.
Sink in like mud.
So how about we say like maybe 0 to 20% is safe, confirmed. 20% to 35 is maybe meh, it could potentially be safe.
We have to test more.
Of course, yeah, we need to take more tests to confirm because there could be other factors. And then past it, it's pretty much guaranteed unsafe.
Yeah. Oh yeah, I think that's good.
You think that's good, Tyler?
Yeah.
Alright.
What are you doing over here, Tyler?
So I'm working on the code right now. So basically, let me give you a little rundown. So first thing we're gonna do is we're gonna initialize our important variables, right? So we got our LCD screen, and then we have our current moisture and the previous moisture from the past like iteration. We'll get into that. Next, we're going to kind of like configure and set up our pins. So we're gonna set up our LCD, right? And then we're going to see right here, we're gonna set up our analog port 1 and analog pin 2 as output and input. And then for debugging, we're gonna start our console window, I guess. Next, we're on the main loop. So basically, we're gonna apply power to the soil sensor, and then we're gonna read the input, right? And then we're gonna turn it off so there's no metal corrosion. And then we're gonna display it on the LCD, which we'll get into that. And then we're gonna start the 100 millisecond delay. So we're not doing it continuously. And then next, this is the actual displaying it on the LCD. if the moisture was the same as the previous moisture, we're not going to do it because there's no point, right? So it's just going to return and stop it. And then now we're going to get the moisture percent, and that's basically this formula right here. So the moisture divided by the max that the sensor will get times 100. Then on the actual LCD, we're going to clear it so there's nothing there. Then we're going to print the like percentage, and then here we're going to determine the state that we need, right? So that if it's above like 36, 35, danger. If it's between like 21, 35, maybe, and then below 20 is safe. And then finally, we're going to set the previous moisture to the current one for the next iteration.
Wow, that's really cool, Tyler. What's this?
So this is the schematic of all the wiring and stuff. So basically, this is Arduino, right? And then this is kind of related to this. So this is the Arduino, this is the soil moisture sensor, and this is the LCD, right? So first thing, we got these ground wires, right, going into our LCD and our sensor, right? Then we have the A0 and A1 ports, pins, that goes into our soil sensor as well. And then up here, we have our SCL and CDA exclusively for the LCD, and that goes in there. And then finally, we also have our 5 volt up here that goes into our LCD.
Very nice, Tyler.
So this is our preliminary design of our sensor to detect soil moisture. We have the Arduino because that's just what we're going to be using for all of our sensors. We have the breadboard to organize the wires that are connecting the Arduino to the moisture sensor and to the LCD screen. We're obviously using a soil moisture sensor so that we can see how much moisture there is in the ground for possible farming and agricultural needs. We have an LCD screen so it's quicker and easier to see the moisture of the ground. And the whole idea is we'll be placing a bunch of these around the planet and checking them every once in a while to see how moist the soil gets.
So, the percentage on this LCD screen shows the amount of moisture in the soil that's measured by these 2 prongs and how much resistance there is between them. If I were to simulate an increase in the soil moisture, it would increase the resistance and show what percentage moisture it has. 71% would be dangerous, while 9% would be safe.
Alright, let's run this out.
Wait, let's do
That shouldn't come out like that.
There's no reason to go work.
Oh yeah, it's like not updating or anything.
Well, is it connected?
That's like.
Or just recording.
Oh,
Alright, let's stop this in.
Yeah. Let's see. Oh, it's not even
Oh,
connected.
they're just not connected. That's the problem.
That,
Okay.
that makes a lot of sense.
That should fix it.
All right.
Something I learned about the moisture sensor is that it functions very similarly to a water purification sensor in the same way that they try to detect particulates by measuring resistivity of the conduit of which they send electricity through, and that is converted into a human readable format such as a percentage or particulates.
So I was the software engineer of the group, and one thing that I really enjoyed from this project and learned from is learning how Tinkercad works and the Arduinos and all that stuff. Really, it was a lot of fun learning how the breadboard works, the wiring, the different types of sensors, and especially learning how Arduino, actual Arduinos work, right? Like the different functions, the loop, all those sorts of things.
I learned with the moisture sensor that the higher the resistance, the less moisture you will have, and the lower the resistance, the more moisture you would have.
Sir, what have you learned? Well, I learned that we can use an Arduino board and the sensor to properly measure the conductiveness of soil and relatively coincide it with the percentage of water in the soil.
Oh, that's good. All right, so what did you learn?
I learned how a breadboard works and how it connects this electrical signal through being parallel with the other wires.
All right, so Sebastian, what did you learn?
I learned that the water saturation in the soil is what's used to measure soil moisture. So, like how much water the soil can hold in a certain unit of area until the water starts leaving that section of the soil, like until it starts overfilling. That's what I mean.
I learned that you can measure soil moisture through the resistance in the ground.
Hey guys, I'm Roman. Make sure to like and subscribe, or else I'm gonna report you to the IRS for committing tax fraud. Oh yeah!